Let's use StatCrunch to help us answer this question here. So the accompanying table shows the height in inches of 8 high school girls and their scores on an IQ test. Complete parts A through D below. Part A is display the data in a display the data in a scatter plot. Choose the correct graph below. Let's go ahead and look at what the data is. Okay, I'm going to go ahead and open it in StatCrunch. All right, so there's the data that they gave me, and I'm going to use the feature that StatCrunch has, stat regression simple linear, and I'm going to create a scatter plot. I'm going to select the X, select the Y, leave everything else alone, compute. It's going to give me a whole bunch of numbers here. We'll use these in a minute, but first, go to the second page, and there is a scatter plot for us. Now, the scale that they use in StatCrunch won't always match up perfectly with the scale that is used on your homework question. And by scale, I mean the axes here. So like this goes from 90 to 130. This goes from 54 to 66. So first of all, we need to determine which axis would be correct. So X represents the heights, and our heights are all around the 50 and 60 range. So I'm thinking the 91 to 130 is going to be out. So I'm going to stick with the other two that go from 52 to 68, and I'm going to change the scale of my graph so it matches up. So I'm going to click on that little icon, x-axis, and I'm going to change the lower number to 52, the upper number to 68. Okay. And then I'm going to change my y-axis as well. It looks like this goes from, now you can't really see option A, but they're the same. A and C are the ones we're working with here because we said 90 to 130 was ridiculous. So A and C both have y-axis values from 90 to 130, which is pretty close to what I have. But I'm going to go ahead and I'm going to change it up so it's exactly the same. So I'll just change this to 90 and this to 130. You don't have to. If you're comfortable with the way it was, you could have left it. That's fine. This is going to help me pick out the graph a lot easier, I think. And I'm looking between A and C, and I'm just going to find out which one matches now. We have a fitted line here, and they don't have one. So just look at the blue dots and match them up with which graph matches. And I see C matches. So the next thing they want me to do is calculate the correlation coefficient. We've actually already done that. Go back to the first page, and they give you this whole summary of information, the dependent variable, the independent variable. They give you the regression line equation. We'll talk a little bit more about that in 9.2. There's a sample size, but what we want right now is right here, correlation coefficient, R. And this is ours. It's negative 0.056755077. What do they want us to round to? Round to 3 decimal places. Now, if your correlation coefficient has a negative, do not forget it, please, for the sake of my health and sanity. I think we have to round that up to a 7 though, right? Yeah, let's round that up. Okay, so there's our correlation coefficient. And that's all that we need StatCrunch for this problem. We made a scatter plot. We calculated the correlation coefficient. I'll go ahead and finish the problem anyways, but you can stop watching now because I'm going to stop using StatCrunch. But to finish out the problem, it says describe the type of correlation, if any, and interpret the correlation in the context of the data. So the closer your correlation coefficient is to either -1 or +1, the stronger the linear relationship is. This is not close to -1. It's negative, yes, but it's 0.057. We're looking for things like 0.99 or 0.8 or maybe even 0.7 in some cases. This is not even close. This is 0.0 for crying out loud. So I'm going to say there's no evidence of any linear correlation here. And if you think about it, think about what the question was. It was about height and IQ. Does your height really have anything to do with your IQ? Probably not. So interpret the correlation, choose the correct one. So based on our correlation, there doesn't appear to be any relationship, or at least not a linear relationship, I should specify. We did simple linear regression. There are other types of regression. We just did linear. So I do want to specify that. Oops, not that one. Here it is. I think based on the correlation, there does not appear to be a linear relationship between the high school girls' heights and the IQs. So let's find the critical value here. We're going to use this other table here for the Pearson correlation coefficient. We have an alpha of 0.01 and we had a total sample size of 8. So to use this table, I'm going to look at 8, row 8, because that's my sample size. And my alpha is 0.01. So it looks like my critical value is 0.834. 0.834. Now this value is what you compare to your correlation coefficient. If your correlation coefficient is higher than this, or lower than the negative version of it, then you would say, yeah, there's a relationship. But as we can see, our 0.056 is definitely not higher than this. It does not have a greater absolute value. So there is not sufficient evidence to conclude that there is significant linear correlation between high school girls' heights and IQ scores. Yeah, words are hard, but there we go. That doesn't matter. So using StatCrunch, remember what we did? Import the data, go away, and you go to stat, regression, simple linear. You really only need to pick just the correct X, the correct Y, and you compute. Gives you all this information. If you want the scatter plot, it's on the second page. If you want to change the scale of the scatter plot, you press this button here. You can choose the x-axis. You can change the scale. Or you could choose to change the y-axis, make the scale. It makes it a little easier to pick out which one looks better. And if you are doing a homework question or something, like a written assignment, and you need to make a scatter plot, you can also use this to help you out. You can take a screenshot or save this to make a nice scatter plot. So that is it for this video. I will see you in the next one.